Welcome back. I'll be discussing some of the topics on complex numbers. Now, we know that there is no real number whose square is negative. So there exists no real number which satisfies the equation, that is x square plus 1 is equal to 0. Okay. Euler was the first mathematician to introduce the symbol I, pronounced iota, for the square root of -1. So it is I square is equal to -1. An expression of the form, the complex number, which is x plus iy, which is denoted by z, where x and y are real numbers. A complex number may also be defined as a ordered pair of real numbers and may be denoted by x comma y. We write that as z is equal to x comma y. Then x is a real part and y the imaginary part of the complex number z, and we write that as real part of z and imaginary part of z. Now let us see the geometrical representation of the complex number. Now if you look at this here in this graph, you have the complex number, that is z is equal to x plus iy, that is z x comma y, is represented by a point which you notice here, correct, which is p of x comma y. In the figure which is shown, x o x dash and y o y dash are called real axis and imaginary axis respectively. This plane is called Argand plane. This plane is called Argand plane or complex plane or Gaussian plane. The distance of complex numbers from the origin is called modulus. Of the complex number and is denoted by mod z is equal to square root of x square plus y square. The angle of the complex numbers with the positive direction x axis, however x may lie in the first quadrant is called amplitude or argument of z, and that is amplitude of z, or it is also called as argument of z, which is tan inverse of y by x. Okay. Now let us see, if I have been given as x square y minus 2 plus I into x plus 2y x minus 5 is equal to 0. Okay. Let us find the values of x and y. So let us equate this to x square plus x square y minus 2 plus I into x plus 2y x minus 5 is equated to 0I. Now equating the real and the imaginary parts of both sides, we get x square y minus 2 is equal to 0, which implies that y is equal to 2 by x square, and the imaginary part here, which is again equated to 0, is equal to 0. Now substitute this y value, which you earlier got, in this equation. So if I substitute it, I get a quadratic equation which is x minus 1 into x minus 4 is equal to 0. Now you got x values which is 1 and 4 as well. Now when you got x is equal to 1, I get y is equal to 2. When I put x is equal to 4, I get y as 1 by 8. So I got these two values, which is x and y. Okay, let us see one more problem. Now write the polar form of 1 by 2 minus I root 3 by 2. Let us write the polar form of this. Okay, so here r cos theta would be minus 1 by 2, and r sin theta is minus root 3 by 2. Now squaring and adding, we get that is r square sin square theta plus r square cos square theta, which is equal to 1 by 4 plus 3 by 4, which results 1. So we know that cos square theta plus sin square theta, which is 1, so you get r square, which is equal to 1. This implies r is equal to 1. Now dividing this, we get, which is tan theta, which is equal to root 3, which is equal to tan pi by 3. Okay. Since minus 1 by 2 comma minus root 3 by 2, this lies in the third quadrant, so the principal value of theta is minus pi by 3, minus pi. So you get this as minus 2 pi by 3. Okay. Therefore, the polar form of this would be cos minus 2 pi by 3 plus I sin minus 2 pi by 3. So thank you for listening. We'll continue in the next session.